And we have persuaded Emily to come across, carry on enthusing everyone about Phoridae. It is going to work. I have faith. And to talk about Henry and the impact that Henry has had. Yeah. Happy? Can you wear this? Where did we meet in? We meet in Rhino?
No, we met at the R.H.L. There's actually a picture of it in the.
Oh, okay.
I don't know if I can pin this. I'll just hold it. That's fine. Thank you everyone for having me. This is my first meeting, and when Erica asked if I would come, I thought that this was a perfect opportunity to talk about the most important collection of Diptera in the entire world, which is based here in Cambridge. So this is the R.H.L. Disney Phoridae collection. And so I have a few projects ongoing with this collection. And so I call this Evolving a Legacy for the Taxonomic Future. So how do we take a collection that contains decades worth of wealth and make it even more important for the generations ahead? So that's what we're trying to do. So there are a lot of people involved. So I'll just say thank you to all of them right now. And of course, Henry is probably the most important one. So back in 2014, I started working on an urban biodiversity project in Los Angeles. I worked for Brian Brown, and Brian Brown is one of the Phorid people. And I was a technician, and my job was to sort insects from the samples. And then because he works on phorids, we sorted out all of the phorids. And then we were tallying the phorids. But this is what the tallies looked like when we started. And so if you can see, we had some non-Megacilia, and then we had very few Megacilia species. I think Megacilia agaricea, Megacilia nigra, Megacilia scalaris, sulfurizona, and that was about it. And the rest of them were going into separate vials, and they were being set aside. And as a person that likes to complete things, this was really frustrating to me because I didn't know what was going to happen to them. And so I said to Brian, I said, what is happening with all of the rest of the phorids? Most of the phorids are not being dealt with. And he said, well, we need to come up with a plan for those. And so I started working on them, and I said, well, I think that I can tell some of them apart. And he said, well, if you can tell some of them apart, then by all means continue. And so I started doing that, but I quickly realized how difficult Megacilia really are. And so I said, Brian, I need to go have tea with Henry Disney. That's literally what I said to him. And so you can see that in the beginning, that's what our tallies look like. I did come, spent time with Henry, and pretty soon this is what we were doing. So we still had a lot of unnamed things, but we made rapid progress because I came to work with Henry and I learned a lot about Megacilia. And this is an actual picture of what greeted me the first day that I walked into Henry Disney's office. So it's a quote from Stephen Marshall's book, Megacilia is one of the largest, most biologically diverse and taxonomically difficult genera in the entire animal kingdom. So that was sitting waiting for me with my access card. And Henry said, if I wanted to give up, the physics department was down the hall. But I did get to have tea with Henry. So this is having tea with Henry. I also got to see the experiments that Henry was doing in his backyard. These are coconut halves. That maybe he still has, but he was rearing Megacilia out of spiders in the coconut halves. We didn't just look at phorids, we also went punting. So that was a lot of fun. Here we are, well, I'm not in the picture, I was taking the picture, but up at Grantchester Meadows. So that was a lot of fun. This is part of my family and some family friends. So we all got to hang out with Henry, not just me. And I came back. For quite a few years, I would come back during the summer and I would spend weeks at a time working with Henry. This is me at the scope, very excited to be using Henry Disney's microscope, me taking pictures of the collection. That's the collection up there on the left, if you haven't seen it. And that's what the drawers, the individual drawers look like up there. And so, and we even put up a malaise trap in Henry's backyard, and I got to take home samples from his backyard. And then there's Erica and I looking a decade younger. But I came back year after year. I learned a tremendous amount from Henry, and then I entered my molecular phase. And this is what ChatGPT thinks I look like in my molecular phase. In all honesty, I'm going to continue with my molecular phase. A lot of the work that I do is molecular, but I am happy to say that what I am now concentrated on doing is taking a lot of the high-tech things that I did between 2017 and 2024 and applying those same tools to now combining the data sets we have with historic collections to make the most out of everyone's data. So it's the return to the collection. So Henry Disney's collection contains approximately 1,800 species, and about 800 of those are Megacilia. So Olga's talk nicely set this up because I do not work on anything but Megacilia. So all of the brilliant Phorids that she showed you, I do not get to work on. I work on all of the small, some shade of brown ones that do not have all of those exciting effects. But I'm here to show you why they are so exciting. So the first project that I'd like to talk about is a PhD student that worked under me, Valerio Caruso. So this is his work. And this is updating and expanding the key to European Megacilia from Disney's Britain to a continental fauna with 393 additions and 4 new species. So you almost forget the 4 new species, although he was most proud of those. But the 393 additions are something that I think many of you maybe could benefit from. And certainly the new book maybe could include this reference, because basically what we did is that Henry Disney's 1989 key to Megacilia originally included 221 species, and it had become the de facto key to European species. So all of us that work on Megacilia had been using it in this way for quite a while. And this was actually based on a file card system that Henry has in his lab. And so when you would get to a certain couplet in the key, you would then go to the file cards and you would open them up and you keyed it out to couplet 100 and you'd go to the file card system, you would pull out card 100 and it would tell you what else might be there. And sometimes it was 1 species, sometimes it was a dozen species. So Henry had already been doing this. He had been compiling this for years. I later digitized it. And then my student Valerio went through and made it complete. So 393 species. This now will include all of the Palearctic species with where they key out in Henry's key, 2 upcoming additions from Henry, and Palearctic species of the Arabian fauna, which already have their own key, but they're also included. Also, the 4 species new to science from an analysis of 9,000 specimens. So this is what it looks like. So any of you who would like to try your hand at keying out a Megacilia, you will now be able to do that for the updated European fauna. And this is what it looks like. So wherever you get in the key, of course, you can look at where you got in the key and what species that is. But you also take a look at this and you have the species, where it was found, the author, the year, and you have the full citation so you can go and take a look at it. So I think this will make Henry's key an invaluable resource for us all. Of course, the optimal thing would be to have an entirely new key, but that is not on the horizon at the moment. So this is a really great alternative. So this will be out soon. It came back with minor revisions from the European Journal of Taxonomy, so please look for it if you would like to identify Megacilia. All right, then another project. So from specimen to story, spatial and temporal diversity patterns in the R.H.L. Disney collection. So this is a project that Anna, who's here, she's working on. She's a student here at Cambridge. And essentially what we want to do is we want to do a comprehensive cataloging of Henry's collection. And then we want to look at the diversity patterns. So we all know, and it was discussed earlier today, that there are many biases in historic collections. We want to look at Henry and his biases. So we want to look at what was collected where over time, how many specimens of different species do we have, where are they from, etc. So Anna has already been working a bit on this, so I begged her to create a few slides of preliminary data. So far we have analyzed 723 slides from the British collection, 462 male, 268 female, and if you are very quick at math, 1 is undetermined. And this is what we have found so far. So these are all of the species of Megacilia that we've looked at. This is only from the British collection. And this is based on another project, which I will go into last. But as you can see, many of the species are singletons, and many of them have 12 specimens. And so we're guessing that Henry caps his series at 12 specimens. And not that mysteriously, most of them were found with 12 specimens. We also looked at when they were caught. So not surprisingly, most of them were caught between May and August, and very few of them were caught during the winter. And then we looked at where they are. So this is the British collection, but there are specimens from outside Britain included in the British collection. It just means that they occur in Britain. So 87.7% are from within the UK, but then we have other locations such as Norway, Germany, Russia, and Ireland. All right, now the last project I think is potentially the most exciting. This is the project that Anna is drawing her data from, and she's also involved with that. This is led by David Williamson. He's a postdoc in my department up in Norway. And this is barcoding with wings and machines. So the challenge. So again, this is a picture of Henry's collection, and right now we are only dealing with the cases 11 through 15. That is the British Megacelia. And the challenge is that we have thousands of flies sealed in glass, and so we can't barcode them. And everything that we do in modern inventories is based on barcoding. And so we really want to connect all of the data from Henry's collection to the modern inventories that we have thousands and thousands and thousands of data points for. So we are systematically going through, and Anna is doing this, Mark is doing this, taking photos of the wings. And this is the order that they're doing it in. It's very systematic. We are about a third of the way through. So 850 specimens, more than 100 species in. And this is what the slides look like. So obviously, standardization when you're taking photos is a huge thing. So we're dealing with the challenges. Luckily, Henry mostly keeps things in more or less the same place. So we don't have to do a lot of adjusting, but we also have to look at the labels. We have to transcribe the data and put all of this into a data sheet. So the solution that we've come up with is to use the wings and use morphometrics to match the wings in Henry's collection to the wings of barcoded specimens. And most of the time when people think of wing morphometrics as a solution for species identification, they think of something like this, tons of cells and points, and it'd be just amazing. But of course, with phorids, it looks like this, and people think, how on earth could you possibly match up species with these wings? But this has actually already been done. So this is a figure from Brown et Wong 2021. And Brian Brown has already been using wing morphometrics, and we have actually used it in several papers. We matched a holotype to fresh material using wing morphometrics when we didn't have any other option. So we know that this works. But the question, we had a few questions about this. One, could we automate it? Because to sit there at a computer and hand landmark all of these points is very, very time consuming. So can we automate it? Two, do we need all of these points? Or can we use a subset of these? And three, do we really need these points at all, or can computer vision solve the problem for us? So we went to machine learning first. And this is the picture of a wing that has been hand landmarked. I have a Fulbright student right now who has already done several hundred of these. Anna is now working on landmarking these. But they are hand landmarking, and we chose 14 points. We did this in consultation. Brian Brown is involved in the project. We did this in consultation with him. Which points did he think were the most important and why? And so we're running with those and hoping that that works. So this is Erin, my Fulbright student. Those are her landmarks. This is the same wing with computer done landmarks. And as you can see, it's doing a pretty good job. It's not perfect. You can see that there are small adjustments that need to be made, but this is after a few hundred wings. So we do expect that the system will improve even more. But what does this data look like? Well, that's what it looks like if you just stack all of the wing points on top of each other. So you can see that we do definitely have variation in where these landmarks are, which is a good sign. If you look at the actual size of the wings, you can see that we have quite a spread in the size of the wings. And one of the interesting things with that is I had my postdoc message me and he said, are females typically larger than males? And I said, yes, that's typically true. And he said, oh, good, because that's what I'm seeing. And as you can see, all of the outliers that are the largest specimens are all female, and that's what we would expect. So that's a pretty neat result that we could see almost immediately. And so all of these are colorful, but the question is, does it work for species identification? Can we actually use this system to match to our barcoded specimens? You probably can't tell from this figure, but maybe you can see that there's a little bit of clustering of the colors. So there are actually 100 different colors here, but maybe you can see that there's a bit of clustering of the pink and the blues, but we can visualize it a different way. Now this looks very messy, but as you can see, some clusters are very, very clean. And that's what we would like them all to look like, but they don't. And so now we're in the process of figuring out, do we have wings that we're missing a data point? Do we have potentially a wing that was mislabeled? Do we have wings that are clustering in more than one place, indicating maybe we have a couple of species? So this is just a very first look. This will get much cleaner quite quickly, I think. And that's just with the labels to show you that all of these species are grouping. I think if we took away the 10 messiest ones, this would actually look a lot better, but I didn't think to do that. This is another look, and as you can see here, it's pretty easy to see the clustering here of the different colors. Well, maybe not easy from way back there, but you can see a lot of the clustering. So I have a lot of optimism that we can clean this up quickly. And there we circle just a few to kind of show how they're clustering. And so the end result of this will be that we will use this wing morphometric approach, and we will barcode the most important collection of megacilia in the world by using machine learning. And so this will be a huge step forward, because then we can essentially apply barcodes to Henry's collection, but we can also apply all of Henry's names to all of the modern molecular inventories. And here is our workflow. So we have Henry's collection. We are photographing the wings and transcribing label data. I have Mark's picture there, but this is also Anna. Then my student Erin is doing the manual wing landmarking of a subset of the images. Anna is now also involved with that. And then David is doing the machine learning, and then automatic landmarking applied to the images. On the other side, we have the barcoded Swedish Phoridae, which will also go through slide mounting and will photograph the wings and then go into the analysis. So then we'll have that analysis with the machine learning. Excuse me. We will compare that to computer vision, and then we will assess the similarity of the wings according to species, resulting in the virtual barcoding. And then on the side, of course, we will have a complete catalog of the spatial and temporal diversity of Henry's collection. And that is it. I'd like to most of all thank Henry for the many years of inspiration and for all of the access to his collection and for providing this invaluable resource. I hope that all of you will use some of these tools in the future, and thank you all for listening.
Any question?
Just to clarify, so if Henry's collection is British and you're using Swedish barcodes, is there a plan to populate the British Phorid barcoding reference library as well, or are you starting with this as an initial review?
So we're starting with using a Swedish collection because I have 32,000 individually barcoded Swedish Phorids, and there's a lot of overlap with Britain. And so I think that we will get a good portion of the way to the answer that we're seeking with that, but then we will continue from there.
Silence the room.
Everyone does not want to work on megacilia. They would like to work on the fantastic Phorids that Olga presented.
Anymore. Okay. Thank you. I guess with that, it just comes to me to say the closing remarks. First of all, thank you all again to the speakers. Please, can you give all of them another round of applause? They were excellent.